The giant squid, a near mythical monster that lives in the deep ocean. There are other creatures there, so strange and bizarre they could come from a nightmare. Others are exquisitely beautiful and dazzle us with their lights and colours. Almost all live at depths of around 1,000 metres that we've only just begun to explore. Now, however, we are developing technology that can take us to places where the ocean is 10 times deeper. An international team of scientists is setting out to discover what, if anything, lives at these much greater depths. Down there, the water pressure can be 1,000 times that at the surface, and there is little food. Until recently, many scientists assumed that such waters must be barren. How could any creature survive in such conditions? We now know that there is life down there, but we still know very little about it. This is an expedition to explore the Earth's deepest frontier. We are heading for the middle of the Pacific Ocean. The sea floor between Japan and Australia is cut by an enormous marine trench that stretches for 2,500 kilometres. It's the deepest in the world, the Mariana Trench. Such immense trenches are rare, and most are found in the Pacific. Around its rim, there are deep cracks created by movements far below in the Earth's crust. At many points along them, that has created a series of underwater trenches. To dive here is to enter another world. As we descend, it gets darker and darker until 200 meters down, there is hardly any light at all. Many of the creatures living here have huge eyes that enable them to gather what little light there is. And some produce their own light. Below 1,000 meters, there is no sunlight whatever. Finding food in the blackness is not easy. Some fish here have gigantic mouths so that they can tackle almost anything edible that comes their way. Others stand on stilts above the sea floor, waiting for a meal to drift by. The pressure in these black depths is immense. An experiment with a large steel ball shows how great it is. Under pressure equivalent to that at depth of 2,000 meters, the thick steel walls collapse. How can animals living in such conditions survive? The bodies of most marine creatures are largely made up of water, which is uncompressible, so such creatures are not crushed by it. But below a certain depth, the huge pressure creates a different problem. Where the seafloor drops to more than 6,000 meters, the pressure is so enormous that it destroys the structure of the cells of which an animal is made. This part of the ocean is called the Hadal Zone, and here life is near impossible. But not totally. There are a few living things here, but they're very few and hard to find. The expedition's aim is to look for them in the Mariana Trench. Scientists from one of Japan's leading deep-sea research institutes are leading the project. The first stage will be to send down a platform and establish it on the sea floor. They call it a lander. It carries a high-resolution camera specially modified to work at these extreme depths. Pieces of raw fish are attached to one of the lander's arms to attract any deep-sea creatures that might be down here.
I'm not sure what kind of marine life we'll be able to capture on camera, but fingers crossed.
The lander is ready to go. The water is crystal clear. Slowly, the lander descends. The Mariana Trench is thousands of miles from land, and these seas contain very few nutrients, so there's little food here for marine life. Nearly 3.5 hours have passed, and at last the lander is nearing the bottom. It's over 8 kilometers deep. Here, the water pressure is 800 times that at the surface. What kind of creature could survive here? And will the camera on the lander glimpse them? They recognize them. They're amphipods, shrimp-like creatures about 3 centimeters long. Until now, they have only ever been found in the Hadal Zone. They seem to have little difficulty in dealing with the enormous pressure. The lander's camera is programmed to be turned on for an hour every 3 hours. Now the team will have to wait until it switches on again.
Wow, look at that!
There's been an extraordinary change. The bait is covered in amphipods.
This is incredible. It looks like a pile of sushi.
Every time the camera turns on, the numbers are greater. The amphipods has stripped the fish bait down to the bones, but the amphipods themselves might now attract other hungry, bigger creatures. The scientists watch intently. The lander is 8,178 meters below the surface. No true fish has ever been seen this deep. If one appeared, it would be a record. The lander has been sitting on the seafloor now for 18 hours. The team are beginning to lose hope of seeing anything new.
Hey, what do we have here?
This is a strange-looking creature, and it seems to be some kind of a fish. It looks a little like a tadpole, but it clearly has a backbone. It's about 20 centimeters long and must be a fish of some kind.
There it is again, at the bottom.
The researchers think it may be the same species as one discovered in another part of the Mariana Trench by another team 3 years ago. It's known simply as the Mariana snailfish.
It's definite proof that fish can actually come down to this depth. We did it! Only one fish was found in the 18 hours. It must mean the population density is very low. That's probably what this indicates.
When the lander was lowered again to 7.5 kilometers, it also recorded some exciting pictures. A huge white amphipod, a giant, more than 10 times the size of the first they saw. It's called the supergiant amphipod. And after some time, the lander is surrounded by ghostly white shapes, more Mariana snailfish. They're attracted to the small amphipods feeding on the bait. Their eyes can probably see little in the dark, but they have special sensory pores around the mouth that allow them to detect movements in the water. The snailfish appears almost waif-like, and yet it must be tough to withstand conditions here. No other fish is known to live as deep as this. To understand just how animals survive at these extreme depths, a team of international scientists has come together. They all bring different skills to the table, and all are passionate about uncovering the mysteries of the deep seas.
So our target there is 8,200 meters.
They're now planning to capture a snailfish alive at a depth of 8,000 meters so that they can examine the workings of its body in detail. Dr. Jeff Drazen is from the United States. He's been working on the ecology of the deep sea for many years.
If you go to the top of Mount Everest and look around and say that there is snow and ice and that is Mount Everest, you miss most of that mountain, and it is the same thing with the trench. So it's very important now for modern hadal investigations to sample the entire trench, various depths and various different kinds of habitats within this place.
Dr. Alan Jamieson is from Britain. He's an expert on the deep sea and has been at the forefront of designing technology to explore it.
Okay, so we've got two systems that are going to be deployed today looking for the snailfish. The first one is a baited camera. We have baits on the seafloor here, and it's been filmed by two separate cameras. So this second system is a large fish trap, so this would lure snailfish into the trap and recover physical specimens. Quite often the depths we're working at are so unknown that quite often we see things for the first time. And that's what's incredibly exciting. My passion. Deepest places. Places where no one has been before. Places where no one dared to go before.
The team will use a range of different landers designed in different countries. Each will be lowered to around 8,000 meters, the depth at which snailfish are known to occur. The first kind carries a fish trap. Once fish have entered the basket, they can't escape. Next in line is the Edoko 1, also designed to catch animals alive and built by a group of small firms in Tokyo.
I'm sure we'll come back tomorrow and we'll have some fish.
The next day, the landers are brought back to the surface.
There. Yeah, I got it. I got it.
The first one up is Edoko 1. There's something trapped inside the net.
But they all look like supergiant amphipod, Alicella gigantea. 7, 8, 9.
Whoa. Standing. This is great.
These amphipods are truly monsters. Like most crustaceans, their bodies are encased in hard shell-like armor, and they have sharp pointed tails.
They use these tails so fish can't eat them. They use that. Fish tries to eat and it gets poked.
Yeah.
All of this here is just oily fluid that helps it float. You'll see it in the videos, they kind of float. So there's almost no muscle there. Nothing to eat.
The supergiant amphipods are the largest in the world and could grow to over 30 centimeters in length. How they do so is still a mystery. The fish trap has also returned.
Right there.
Good fish. Right here. Here. Very nice.
And it's brought back what they'd been hoping for, a snailfish. It's rushed back to the lab for immediate examination.
Okay, so this is one of our little snailfish, the Mariana snailfish. That's perfect, I think. We are very excited. We've been working on it for a long time. So.
The body of the fish is soft and gelatinous. It has no scales and its skin is transparent, so one can see right through it to the muscles beneath. Its small eyes are probably useless, but no one knows for sure. Some blind fish still retain rudimentary eyes underneath the skin.
So fish have a number of sensory pores on their heads, and do you see them? Yeah.
Most of the snailfish's pores are located around its mouth and are used for detecting movements in the water.
But they go away very quickly. Magic disappearing pores, they're gone now. Okay.
The skin is extremely delicate and the pores disappear almost instantly. The researchers quickly make a note of the position of each pore.
And then this is underneath looking up, so this is the mouth here. On the underside of the jaw you can see lots of little holes, but there's some very, very small ones behind the eyes and coming down the sides of the head, like a little sensory, so it's vibrations within the water.
The pores probably help the snailfish hunt for prey in the darkness of the deep. Even the tiniest movement made by a small crustacean will be picked up by these specialized organs. A closer look at the bodies of deep-sea fish is also starting to explain how they survive the extreme pressures of the deep sea. Dr. Paul Yancey has been trying to answer this question for a long time. His research has led him to a substance commonly found in saltwater fish. It's called trimethylamine oxide, or TMAO.
It's a chemical that most people are probably familiar with if they've been to a fish market. It's that faint fishy odor that is coming out of all these different species here. And TMAO helps animals survive the high pressure of the deep.
The water pressure in the Hadal zone is so great that it almost destroys body cells. But exactly how does that happen? There are proteins inside the cells that carry out essential life functions. It seems that under high pressure, water molecules are pushed into the proteins and stop them from functioning. And this is where TMAO helps. It binds tightly to the water molecules and prevents them from disrupting the way that the proteins work. Dr. Yancey has discovered that deep-sea fish have higher levels of TMAO than others, and the Mariana snailfish has the highest of all. This remarkable finding suggests that the Mariana snailfish may be better adapted to life in the deep than any other species. The Mariana Trench started to form around 50 million years ago. That's relatively recent in Earth's long history, but few creatures alive today seem to have evolved ways of surviving in its depths.
We think that fishes evolved in shallow waters, and most of the major groups of fishes have not made it into the deep sea. So it seems to be very difficult for animals to evolve the ability to work under pressure. So we imagine it's taken millions of years and only a few types of fishes have made it down.
The team are preparing to launch another lander to get some more footage of the snailfish in their natural habitat. They wait eagerly to see if their bait attracts any visitors.
Oh, there he is.
There are snailfish here.
2 of them, there's 2.
Oh, so there is.
Yeah.
That was cool.
The lander has settled on the ocean floor at about 8,000 meters below the surface. The bait has already attracted both amphipods and snailfish, and the team get a wonderful view of life in the very deepest part of the Earth's oceans.
Look at that. He just ate.
That's fantastic here.
To their delight, the camera is recording a fish feeding on amphipods. It's just the kind of behavior that the researchers were hoping to see. The snailfish may look like a harmless tadpole, but it has some formidable weapons. A CT scan reveals the details of its internal anatomy. It has over 100 sharp teeth that ensure its prey can't escape. And at the back of the throat, there is a second set of jaws with more teeth. It's a complex system that enables the fish to crush and grind food and so feed on a great variety of prey. And it may be one of the reasons why the Mariana snailfish is able to live at such extreme depths where food is so scarce.
In the deep sea, you kind of don't know when your next meal will be, so you want to be adapted to eat anything that you can find. Maybe that's where they are devoting their energy, is to making a very strong jaw for crushing prey. They do seem quite fragile, but seem very successful.
We are beginning to get some understanding of how the Mariana snailfish and other deep-sea creatures manage to survive in the deepest parts of our oceans. The first to gather at a fresh carcass are these scavenging amphipods. Following them come larger predatory amphipods. And these, in turn, are hunted by Mariana snailfish, which crush the amphipod shells with their specialized jaws. Astonishingly, there appears to be an entire community of animals that flourishes as deep as 8 kilometers down in the sea. But what does the smallest of these creatures usually feed on? These amphipods are scavengers that eat dead and decaying matter. But very little food ever reaches these depths. Now, new research has shown they don't rely just on the occasional animal carcass, but also on something more surprising: driftwood. Wood is notoriously difficult to digest, but the amphipods have evolved a powerful wood-busting enzyme that can break it down and extract energy from it. Chunks of wood do sometimes sink into the ocean trenches. These may form a significant part of the amphipod's diet and enable it to live where few other creatures can.
We have a long ways to go in exploring the deep ocean. We have a lot of questions left. And we're just going to have to keep exploring the trenches to try to find it and to try to answer a whole lot of other questions that we have.
The team are now heading for a location near the entrance of the Mariana Trench. This time they're dispatching a remotely operated vehicle. An ROV. They're hoping to find a place that was discovered several years ago, 5,700 meters below the surface. The ROV moves along the steep rocky slopes of the trench. And as it comes round a corner, it finds what they've been looking for. It's a ghostly sight, resembling the stalactite formations in a dark cave. And there is also life within this strange underwater landscape. A tangle of deep-sea tube worms. And on the sea floor, a bed of giant white clams. They've not been seen in the trench before. All these life forms can only exist here because the water seeping from deep below is rich in dissolved chemicals which can be converted into food by a whole community of deep-sea creatures. The seeps in the Mariana Trench are still mysterious and largely unexplored. The expedition is now heading towards the deepest part of the Mariana Trench. It's a slot at the southern edge called the Challenger Deep. On the 23rd of January 1960, the US Navy made history by sending down the first manned deep-sea vessel into its depths. Its two-man crew sat inside a small sphere on the underside of the submersible. The rest of the ship was a float chamber filled with gasoline to give it buoyancy. And the two men who attempted the journey were Lieutenant Don Walsh and scientist Jacques Picard. The descent took nearly 5 hours, but they reached the bottom and a depth of nearly 11 kilometers. The submersible that made this historic voyage is called the Trieste and is now kept in the US Navy Museum in Washington. Don Walsh remembers the epic journey well.
As you can see, this window here is not straight ahead. It's pointed down at the seafloor.
He claims to have seen something remarkable on the ocean floor.
We had outside lights, which are on the bottom part of the balloon here. So we could see from here out to about 10 meters on the seafloor. Well, just before we landed on the bottom, we saw a flatfish, like a sole or halibut. Jacques was at the window. He said, "Come here, look, fish." And he moved away from the window. I moved up, looked at it, and that's what it looked like to me. And this is almost a quick snapshot, because as soon as we landed, poof, our vision went away.
This is Don's drawing of the fish he thinks he saw. But most scientists are skeptical, and they have good reason. Deep-sea fish need high levels of TMAO to withstand the enormous water pressure. But at extreme depths of over 8,000 meters, it's thought that the fish would need so much TMAO that their bodies would cease to function properly.
I know that many marine biologists, fish specialists, said we didn't see a fish because one couldn't live at that depth and so on and so forth. I'm willing to allow or admit that maybe we didn't see what we saw. But for now, until you can prove us wrong, I'll have to stick with fish because I know what a fish looks like.
After the descent of the Trieste over 50 years ago, only unmanned vessels made the journey into the Challenger Deep. Then in 2012, film director James Cameron became the third man to descend to the bottom. In the small area of the trench that he explored, he saw a number of deep-sea creatures, but no fish. The question as to whether there are fish in the deepest parts of our ocean is a fascinating one. Japanese scientists have teamed up with filmmakers to develop a new type of ROV that might be able to answer the question. It's one that can move freely along the ocean floor at a depth of 10,000 meters. All its parts are specially designed to be able to withstand extreme pressure. It's taken a whole year to complete its construction. Now the ROV is heading out into the Challenger Deep for the first time. The engineers carry out the final safety checks. The ROV is equipped with high-resolution cameras that can be operated from the surface. It's a unique system where the ROV and its launcher are dispatched together. The two parts are coupled together during descent, lowered by a main cable from the mothership. At 7,000 meters, the smaller vehicle is separated from the launcher, and a 1mm fiber optic cable is now the only connection between the two. Once uncoupled, the lighter vehicle can move around more freely to explore the ocean floor. It's 4 in the morning. The team prepare to launch the new system. It will take 6 hours for the ROV to reach the bottom, so they start well before dawn. The ROV sends back images to the ship's control room as it descends.
– 1,000 meters.
After 3 hours, the ROV and launcher are 7,000 meters down. They will now be uncoupled.
All systems go. Commence separation.
Everyone is on edge. During testing, the thin fiber optic cable repeatedly snapped at this stage. They watch nervously.
It's free. Keep going. Ah, good. It's all right. Separation complete. Time 7:57.
This is nerve-wracking.
The uncoupling went without a hitch, and the ROV continues its dive to the bottom of the trench.
— 8,000 meters.
It's now beyond the depth at which fish can survive. —
10,000 meters.
And it's more than 10 kilometers below the surface.
"50 meters to the bottom."
The countdown to the bottom has begun.
30 meters. 5 meters.
It's hard to see the seafloor.
Are we seeing it?
Ah, there it is.
Yep. That's definite.
But after 6 hours and 20 minutes, the ROV has finally reached the bottom. This is the deepest place in all the oceans of the Earth. The temperature is 2.4 degrees above freezing, and the ocean floor is covered by a thick layer of sediment. This barren lunar landscape seems lifeless. The ROV slowly starts to move across the ocean floor. The water pressure at this depth is so enormous it's equal to a 1-ton weight placed on the end of your finger. Can anything really survive here? The team watch intently for any sign of life. And there it is, a small white shrimp-like creature. Given the enormous pressure it's under, it's swimming with surprising speed. It appears to be an amphipod. It's the first time one has been observed at this depth.
Here. This.
The team have spotted something else. It's a type of sea cucumber, a soft-bodied marine creature. Its closest relatives are starfish and sea urchins. Most sea cucumbers feed on plankton and waste matter on the sea floor. The researchers have not seen this kind before. It could be a new species. Then the ROV finds even more. The ocean floor around them seems disturbed. It looks like they've been feeding. Sea cucumbers do that by sucking in sediment and filtering out the edible particles. The rest is ejected and returned to the sea floor. The ROV then continues on its journey. The researchers are thrilled. They never imagined there would be such large numbers of sea cucumbers at this depth. These animals are all aligned in the same direction. That suggests that there is a current flowing along the bottom, and the sea cucumbers may be facing the flow to save energy. So it seems that the deepest reaches of our oceans hold more life than we once thought possible. What appears to be a desolate landscape is in fact home to some highly specialized creatures. But how is it that sea cucumbers and amphipods are not crushed to death by water over 10 kilometers deep? Recent research has revealed that another chemical substance may hold the answer. It's been found in large quantities along with TMAO in deep-sea amphipods, and it's called silo-inositol. It has a flat molecular structure that may allow it to wedge itself between protein molecules and counteract the effect of water pressure. And silo-inositol may protect proteins in a way TMAO cannot. TMAO will only work up to a certain depth. In deeper waters, the proteins stick together and cease to work properly. If silo-inositol is present, it may wedge itself between the proteins and restore their function. We don't yet know whether other creatures that live in these depths have high levels of silo-inositol. And it's not inconceivable that some fish could make use of a substance like this. If so, then Don Walsh could have been right when he claimed to have seen one some 50 years ago. Our expedition's dive into the deepest part of the Mariana Trench has revealed sea cucumbers and amphipods, but it's been unable to find any fish. For now, this will remain one of the unsolved mysteries of the trench. While deep-sea exploration has unraveled some of the mysteries of our oceans, one question continues to puzzle scientists. Where did the animals that live in the Mariana Trench come from? Dr. Hiroshi Kitazato has studied deep-sea creatures for many years and has an extraordinary theory.
DNA analysis of the life forms in the Hadal Zone has made great progress in recent years. Based on those results, we can say with some degree of confidence that these creatures are likely to have come from Antarctic waters.
In fact, the Mariana Trench and the Antarctic have one thing in common. Their waters are very cold and poor in food. The amphipods from the Mariana Trench were also found to have the same cold tolerance gene that is found in Antarctic amphipods. As for snailfish, they are common throughout our oceans, but they're more abundant in Antarctic waters, so the Mariana snailfish may have its origin in the Antarctic seas. There are, in fact, deep ocean currents that connect the Antarctic with the Mariana Trench. Cold Antarctic water sinks to the bottom and flows out along the seafloor into other oceans. In the Pacific, one of them crosses the equator and flows into the Mariana Trench. Animals found in the Mariana Trench today could have made the journey by adapting to their new environments along the way. The trench only reached its current depth 10 million years ago, so the creatures that live here must have evolved relatively recently. Only animals like snailfish and amphipods, already adapted to living in the cold, would have been able to make this epic journey. The Mariana Trench is just one of the many deep gorges hidden beneath our oceans. But it has given us a brief glimpse of some remarkable animals that manage to survive in one of the most inhospitable places on the planet. If creatures like these can remain unknown for so long, what others might there still be hiding in the deep? It's a reminder of how little we still know about the deepest reaches of our oceans.